Hey guys, this is your CPM 2 Module 3 review or practice test. So, we're starting off with some vocab, just like always. So, fill in the blanks, choose the vocabulary listed below each question. So, number 1, identify the name given to 3y in the following fraction. 3y is the numerator. Okay, if it's in the top, it's the numerator. The bottom is the denominator. Number 2, the smallest positive number divisible by all denominators of a list of fractions is called your least common denominator. We abbreviate that by LCD. Number 3, fractions that represent the same portion of a whole are called equivalent fractions. Okay, so numerator, least common denominator, equivalent. Number 4, fractions 5 ninths and 7 ninths. Those are called like fractions. Okay, and those are like fractions because they have the same denominator. They have 9 in the bottom. While the fractions 5/7 and 1/6 is called unlike fractions because one has a 7 in the bottom, one has a 6. So if it doesn't have the same denominator, the same bottom number, then they're unlike. We are going to choose from the choices below each question. Which of the following is the correct statement about proper fractions? So A says a proper fraction has a numerator which is greater or equal to the denominator. That is your definition. Oops, that's way too big. That is your definition of an improper fraction. B, a proper fraction has a numerator which is less than the denominator. Ding, ding, ding. C, a proper fraction has a numerator which contains a variable that has nothing to do with it. So what's the correct choice? Correct choice is B. 6, what are equivalent fractions? So A, equivalent fractions are fractions that represent different portions of a whole. Nope. Equivalent fractions are reciprocals of each other. Nope. Equivalent fractions are fractions with the same denominator but different numerators. Nope, that's like fractions. So then hopefully D, equivalent fractions are fractions which represents the same portion of the whole. So D. And then 7, what fraction represents the shaded part of the figure below? Well, how many parts are shaded? We have 1, 2, 3, 4, 5 shaded parts. So that's your numerator. Out of how many parts total? 1, 2, 3, 4, 5, 6, 7, 8. So 5/8. All right, let's get to the skill and drill on the next page. Graph the fraction on the number line. So again, they've already done the hard part for you on this. This 6 down here tells you how many parts you need to split up between 0 and 1. So because it's 6, notice you have 1, 2, 3, 4, 5, 6 different parts between 0 and 1. So then use this to count over. So from 0, we're going 1, 2, 3, 4, 5. So this right here is 5/6. Number 9, simplify. When you have the same number on top as you do on bottom, it's 1. 62 goes into 62 one whole time. And because we have negative over positive, that makes this a -1. Simplify 24 divided by 0. Because 0 is on the bottom, That makes this undefined. If that was switched, right, if I had 0 over 24, where this is on the top, then that equals 0. And then the only other kind of rule that's similar to these is if you have something like negative 62 divided by 1, then that's going to be negative 62. So those are just kind of, this one here and this one here, just little extra tidbits for you. 11, we need to write the mixed number as an improper fraction. So to do that, you multiply the whole number by the denominator. And then you're going to add that to the top number. So 3 times 7 is 21 plus 6 is 27. So 3 times 7, 21 plus 6 is 27. And then it's going to stay all over the same denominator. So it's going to stay all over 7. 11, we're going the opposite way. So when you go the opposite way, divide. So off here to the side, I need to do 6 divided by 35. 6 goes into 35 5 times evenly. Multiply back out. 5 times 6 is 30. And then we subtract and we get a remainder of 5. So this is your whole number. And then this down here, your remainder, is your numerator. So then my answer is 5 from this 5 up here, and then 5 over. You can either say this number here or keep the same fraction. So this is 5 and 5 6. And check this if you want. 5 times 6 is 30, plus 5 gets me back to that 35. So those are really easy to check. Write the number 54 as a product of prime factors. So whenever you want prime factors, when it says prime factors here, you need to think of your tree. So we'll go 54 and we're going to break it down into nothing but prime numbers. So it doesn't matter how you start this. We can go 6 and 9. I think that's the way most of us will see it. You could do it 2 and, what would that be? 2 and 27. Okay, it doesn't matter how you start it, just keep breaking it down. 6 is not prime, so you can break down 6 to 2 and 3. So after you break down 6, I'm going to just kind of cross out this 6. I don't really look at it anymore because we've broken down 6 to that 2 and 3. And then you can break down 9 to 3 and 3. And so same thing, since I have broken down 9, we're not looking at it anymore. And now, because you can't break down 2 or any of these 3s, then we have these as prime numbers. So you can write this one of two ways. You can either go 2 times 3 times 3 times 3. That's perfectly fine. Or you can write it in exponential notation, which is 2 times 3 cubed, since you have 1, 2, 3 3s. Okay, both of those work. So same thing on 12. Find the prime factorization of 64. Again, prime factorization. When we see that, we need to think tree. So 64 is 8 and 8, which is then 4 and 2, 2 and 2, 2 and 4, 2 and 2. So I'm not looking at this 4 or this 8 or this 8 or this 4 because it's already been broken down. So I have these 2's here, my prime numbers. So this is either 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 6th. Okay, either of those are great answers as well. Okay, and then 13, simplify the fraction. So you only have one x, so that x is going to stay where it is. But then you want to look at these numbers. 6 and 30, what can you divide into both of them? Now, I'm going to do this two different ways. You can either say, well, they're both even, so I know I can divide on both by a 2. So 6x divided by 2 is 3x. 30 divided by 2 is 15. Those can still be broken down, so I can break these down by 3. 3x divided by 3 is 1x, or just x. 15 divided by 3 is 5. Okay, so you can do it in 2 steps. But if you just start from the biggest number, and if you can't see the big number, there's no reason why you can't do the 2 steps. But if you can see right from the get-go that I can divide both of these by 6. 6x divided by 6 is 1x, or just x. 30 divided by 6 is 5. You get the same answer, and this is a lot shorter. So either x over 5 or 1x over 5. Those are both equivalent answers. And you can do it either in 1 step or in 2 steps. You'll get the same answer no matter what. Now we are multiplying. And when you multiply, you just simply multiply straight across. So you do want to kind of look if you can cross reduce. 5 and 12 you can't reduce. 5 is a prime number. 7 and 12 you can't reduce. 7 is a prime number, so just multiply straight across. So 5 times 3 is 30. 12 times 12 is 144. Now, usually you want to look after you're done with your fraction, can you reduce it? But I know because I couldn't reduce either of these ways that I can't reduce this. So this is my final answer. Now, B, on the other hand, we can do a lot of reducing. So, go one way, 15 and 5, those are both divisible by 5. So 5 divided by 5 is a 1. 15 divided by 5 is 3. Now look the other way. 6 and 12 are both divisible by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. So now multiply straight across. We have 1 times negative 1. And 3 times 2. Okay, the other way to do it is to multiply straight across. And I'll do that down here, but I'm going to end up erasing it. So if you just go straight from here, we got 15 times negative 5 over 12. Multiply straight across. 6 times negative 5 is negative 30. 15 times 12. We get 10, carry the 1, 2 plus the 1 is 3. 1 and that is 5. 1 and 1. So 180. So from here, then you've got to look at this and get this to this simplified fraction right here. So big numbers, I know I can divide them by a 10 since they both end in a 0. So 30 divided by 10 is -3. 180 divided by 10 is 18. Now these are numbers I know and I'm a little bit more familiar with. So I know I can divide both of these by 3. So -3 divided by 3 is -1, and 18 divided by 3 is 6. As you can see from right here in the blue versus everything else in the purple, it's so much quicker and easier, and you get smaller numbers to just cross-reduce from the very beginning. Okay, so for the rest of this review, anytime we're multiplying, I'm going to be cross-reducing like I did right here in the blue. But know that you can multiply straight across and then reduce. That's just not the way I prefer to do it. It takes longer, bigger numbers, and I would rather reduce before. Okay, so same thing here on 15. We're multiplying. I just have a variable in it, but same concept. See if you can cross-reduce. Here we got 3 and 5. Those are both prime numbers, so I can't reduce. We've got 7 and 3. Again, both prime numbers. I can't reduce. If you have at least one prime number, you can't reduce anything. So just multiply straight across. 3x times 3 is 9x. 7 times 5 is 35. And you're always wanting to check, can I reduce? But I know, since I couldn't cross-reduce, that I can't reduce. On B, going this way here, we got 3x and 6. I can divide 3 and 6 by 3. So 3x divided by 3 is 1x, or just x. 6 divided by 3 is 2. Look this way now. 35 and 5 are both divisible by 5. So 5 divided by 5 is 1. 35 divided by 5 is 7. So now multiply straight across. X times 1 is either 1x or, again, just x. You don't need that 1 in front. And 7 times 2 gives me 14. On 16, we need to divide. When you divide, you need to do your keep, change, flip. So I'm going to keep this first fraction, so it just comes down. So we get 27 over 7. Change your divide to multiply, and then flip your second fraction. So instead of it being 7 over 9, it's 9 over 7. So check if you can cross-reduce. This way, 9 and 7, 7's prime, so I can't. This way, 27 and 7, 7 is prime, so we can't. So multiply straight across. So 27 times 9. 7 times 9 is 63. Carry your 6. We get 2 times 9 is 18. Plus the 6 is 24. So I get 243 on the top, and then on the bottom, 7 times 7 is 49. Here's another good reason to cross-reduce. We've got big numbers here, 243 and 49. You always need to reduce. If I don't know if it reduces, if I do not check if it cross-reduces. Because I cross-reduced and I know I can't reduce this way and I can't reduce this way, that means I can't reduce after I get done multiplying, so we're done. So it takes out that question of can I reduce, because I've already checked it. B is the same thing. Keep, change, flip. Keep your first fraction. Change your divide to multiply and flip your fraction. So 36 over 11 becomes 11 over 36. Cross-reduce if you can. So when I'm looking this way, 6 and 36 are both divisible by 6. So 6 divided by 6 is 1. 36 divided by 6 is 6. Now look this way. 11 and 11. We can reduce those to a 1. So now multiply straight across. I've got -1 times 1. And 1 times 6. So there's my final answer. Again, I don't want to multiply 6 times 11 and then 11 times 36 and reduce that. That's not going to be fun. And just so you also are aware, this right here is an improper fraction. If it does not tell you to change that to a mixed number, don't worry about changing that. Only change it if they tell you to write it as a mixed number. If they don't tell you how to write it, don't go changing the form of that answer. Okay, if you make a mistake in changing it from this form to a mixed number and this right here is right, I've got to count it wrong if you convert it incorrectly. So don't do more work for me to find more mistakes. 17, find 1/3 of 27. So this word right here, of, means multiply. So I'm just doing 1/3 times 27. Now you can leave it just like this and multiply. If you want this to become a fraction, put it over 1. Okay, not necessary, but if you like fraction with a fraction, I get it. So multiply or cross reduce. Ones across this diagonal can't reduce, but across this way I can. So 3 and 27 are divisible by 3. So 3 divided by 3 is 1. 27 divided by 3 is 9. So now multiply straight across. We get 1 times 9. And 1 times 1. I will take this answer, but I won't lie to you, I don't like it. 9 divided by 1 is 9. No, I lied to you. I won't take that answer because that's not fully reducing it. You got to simplify it. 9 over 1, that's not a hard one. That's 9. Okay, on 18, we're adding. When you add, you got to make sure you have like fractions. So here, do I have like fractions? Yes, I do. Why are these like fractions? And we can even look at B as well. Why is that a like fraction? They are like fractions because you have the same denominator, 13 and 13. Here, 17x and 17x. If they're the same denominator, they're like fractions. These are the easier of the two. So when they're like fractions, you add the top. So 2 plus 5 gives me 7. And then you just keep it over this like denominator of 13. Okay, now, before I box it, I should have asked, does it reduce? But 7 and 13 are both prime. And if you have at least one prime number, it doesn't reduce. So on B, same thing. You've got like denominators. So it means this fraction, this answer is all going to be over 17x. And then add the numerator. So 3 plus 5 gives me 8. Can I reduce this one? Same thing. 17 is a prime number, so we can't reduce it. So that's my final answer. Like fractions are a lot easier. Let's go to some unlike fractions. So on 19A and B, these are unlike fractions. So, when they are unlike fractions, we need to find our LCD, or least common denominator, make equivalent fractions, and then add or subtract. So I'll even write that over here. First, find your LCD, make equivalent fractions, and then add or subtract. Okay, so on 19, again, hopefully you're getting kind of good at these, that you can look at these and see what is your LCD, especially on A. B is a lot harder, but A isn't. When we look at these right here, you can list out your numbers. 3 is 3, 6, 9, 12, 15, 18, 21, and we could keep going, right? 5, 10, 15, 20. What two numbers, right? And this is like 5 times 1, 5 times 2, 5 times 3, 5 times 4, 3 times 1, 3 times 2, 3 times 3 times 4 times 5 times 6 times 7. Okay, we're just multiplying. So you want to look, what is the smallest number that both of these have in common? And that's going to be your 15. So I need to write both of these fractions over 15. So that's step 1, that's my LCD. So now I'm on to step 2, my equivalent fractions. How do I go from 3 to 15? I multiplied by 5, so I'm going to multiply the top by 5 as well. So 5 times 2 gives me 10. I am doing the opposite of simplifying, right? If you had 10 over 15, you say, oh, those are both divisible by 5. 10 divided by 5 is 2. 15 divided by 5 is 3, which is what we started with. Okay, we're going backwards from simplifying. Same thing here. 5 times what gets me to 15 times 3. So we got to multiply the top also by 3. So 1 times 3 is 3. So now I have like denominators, 15. So simplify the top. 10 minus 3 gives me 7. 7 is a prime number, so I know I can't reduce that anymore. Now with B, B's a little bit harder. Because these numbers are so big, if you notice here, we just kind of multiplied these two together. 3 times 5, that's 15. When in doubt, you can do the same thing with these. So I am just going to take these two numbers here and multiply them together. So 36 times 7. 6 times 7 is 42. Carry your 4. 3 times 7 is 21. Plus the 4 is 25. This is what my LCD is going to be. So you get 252 as the denominator. So we got to figure out what we're multiplying together to get those. To go from 7 to 252, what did I multiply by? 36. So if I multiply the bottom by 36, I also need to multiply the top by 36. So 36 times 2 gives me 72. How am I going from 36 to 257? We are multiplying by 7. So if I multiply the bottom by 7, I'm also multiplying the top by 7. So 1 times 7 is 7. So now I have like denominators. So this will stay over 256. Then subtract. 72 minus 7 gives me 65. Now you want to check to see if they reduce. 65, the only way to get there is to do 5 times 13. 5 doesn't go into this one, and neither does 13. So this is fully simplified. Okay, 20, we need to solve and simplify. So, find your LCD first. If you only have one number in the bottom of these, that is your LCD. So here, my LCD is 32. Because my LCD is 32, I am multiplying everything by 32. Not just what has fractions, but everything. If I've got 3 terms in here, right, 1, 2, 3, every term gets multiplied by what my LCD is. So we need to do 32 times x. When I do 32 times 11, hopefully you see that these just sort of cancel out and we get a plus 11. But if not, 32 times 11 over 32, put this over 1, your 32's cancel, we're left with 11 over 1, which is 11. Same thing here, 32 times negative 1 over 32, my 32's cancel, and I'm left with a negative 1. Again, down here, 32 times negative 132, put that over 1 if you want. Those cancel, and I'm left with negative 1 over 1, which is negative 1. So now that I have my equation without any fractions, that's the whole goal of this whole nonsense. Now solve. So to get x by itself, first we need to subtract this 11 over. So 32x equals negative 12. Divide by 32. And so those cancel and we're left with x equals, now here we can divide more. Both of these are divisible by 4. And you can do this in 2 steps if you need to. You can do it by 2 and then you'll have to end up doing by 2 again. But if we go to the biggest one first, it's only 1 step. So negative 12 divided by 4 is negative 3. 32 divided by 4 is 8. 3 is a prime number, so I know I can't divide that anymore. 21, solve and simplify. So, the goal is to get z by itself. So, if you think of this negative 11 as being a negative 11 over 1, multiply by the reciprocal to get z by itself. The reciprocal just means to flip that fraction. So instead of it being negative 11 over 1, now it is negative 1 over 11. Doesn't matter where that negative goes. Okay, as long as you flip the fraction, instead of being 11 over 1, it's 1 over 11. So my 1's cancel, my 11's cancel. You can even think about your negatives canceling, and we're left with z. What I do to one side, I must also do to the other. So if I'm multiplying this side by negative 1 over 11, I need to multiply this side also by negative 1 over 11. Cross reduce if you can. Can't cross reduce here. 1 and 5 are prime numbers, but this way I can. 121, I can divide in an 11. 11 divided by 11 is 1. So when I multiply straight across, I have 11 times negative 1, and I have 1 times 5. Both of those are prime numbers, so I know I can't reduce. And again, this is an improper fraction. If my instructions here don't say to write as a mixed number, don't write as a mixed number. Leave it just the way it is. Because if you get this right and you give me the wrong mixed number, I've got to count off. So don't give me a reason to count off. 22, graph and solve the expression, graph the inequality and express in interval notation. So, first you got to solve this. To get x by itself, we're going to subtract this 5 over. So I get x is less than or equal to -3. So when I graph that, use that symbol as an arrow. It's less than. This symbol here is pointing this way. That means my graph needs to go that way. So at -3, it's going to go this way here. That bar under it means that this is going to be a bracket, not a parenthesis. So in interval notation, you're going from left to right. The first thing I encounter on the left is an arrow. That arrow is pointing to -infinity. So you've got -infinity. Infinities always have parentheses. And then as we keep going this way, what's the highest number it touches? Well, it never touches -2. It stops at -3. And if this has a bracket at -3, I have a bracket in my interval notation as well. Okay, and then last page. In an American Sign Language class of 26 students, 21 are hearing impaired. What fractions of students are hearing impaired? So because we want to know how many are hearing impaired, we have 21 that are over the total amount of 26. Now look at it. Can you reduce? You can't, because this one is only 7 times 3, and 7 and 3 don't go into 26. So that is it. On 24, we need to find the perimeter of the following figure. This one says to simplify and write as a mixed number. So this one we will have to convert if we get an improper fraction. So perimeter means add all your sides. So here we have 8 over 15 plus 14 over 15 plus 11 over 15. As much as you may not like fractions, they were actually extremely nice and sweet to us here. The reason is these are all like fractions, and these are like fractions because you have the same number in the bottom of all of your fractions. So my perimeter then will stay all over 15 and add up your numerator. 8 plus 14 is 22. And then 22 plus 11 is 33. All right, we're close to done. First, before I move this to a mixed number, is this in simplest form? Hopefully you said no, because I can divide both of these by 3. So 33 divided by 3 is 11. 15 divided by 3 is 5. So now that this is in simplest form, convert it. So how many times does 5 go into 11? That is twice. 2 times 5 is 10. Subtract and we get 1. So my final answer here is my perimeter is 2 from up here. My remainder is the numerator, so 2 and 1, keep it over the same denominator, 2 and 1/5. Because we're finding perimeter, we also need units here, so the perimeter is not just 2 and 1/5, it is 2 and 1/5 centimeters. And then our last one, we're not just finding perimeter, we're also finding area. So your formula for area, which has to be memorized, is length times width. Really and truly doesn't matter which one you call length, which one you call your width, but this is technically the length. So 4/5 times the width, 3/5. So cross reduce if you can. 4 and 5 you can't reduce, 5's prime. 5 and 3 you can't reduce because 3 and 5 are prime. So multiply straight across. So 4 times 3 is 12. 5 times 5 is 25. So my area is 12/25 centimeters squared, because we're talking about area. And again, you do want to see, does this reduce? But because I couldn't cross reduce, I know it doesn't reduce. And then for perimeter, add up all your sides. So 4/5 plus 3/5. So that's this one and this one. Don't forget that this one is also 4/5. And this one over here is another 3/5. Again, they're nice to us because these are all like fractions. Why are they like fractions? Because these all have the same denominator. When we're adding, you keep the same denominator, so it's going to stay over 5, and then add the top here. So 4 plus 3 is 7, plus 4 is 11, plus 4 is 14. Check if you can reduce it. You cannot though, because 5 is prime. And so because this is perimeter, we have 14/5 centimeters. Notice I did not change this one to a mixed number like I did here, because this one told me to. This one just said find it any way you want to. So I'm not going to convert that, because again, if you give me this and convert this wrong, I'm counting off. So that is all I have for this review. Rewind this video as you need to, push pause, and ask me any questions that you have.